All right, here we go. Day 2 of Unit 5. We're still talking about ratios. We're going to talk about how to express relationships as ratios and conversions of measurements. So this is sort of like a round 2. A ratio is a comparison of two quantities, A and B, with the same, similar, or related units. So we have a 7:8 ratio, which we can write with a colon, we can write it with the word 2, or we can write it as a fraction. Algebraically, we would say m to n, or the fraction m over n. Express the ratio of 4 goals per game in 28 shots on goal. So because of the order that that's written in, we would say 4 goals per game in 28 shots on goal. So the word in kind of acts like our colon, and the thing that's written first would be 4 goals over 28 shots, and we've got to keep it in the same order. So then we'd want to say, like, can we put a 4 to 28 ratio in lowest terms? 4 and 28 are both divisible by 4, and we would get a 1 to 7 ratio. So we can say the ratio of shots to goals is 1 to 7, or we can say 1 to 7, either of those. And that means for every 7 shots on goal, there was 1 goal made. All right. We can also talk about this as being something that is called discrete. It's a new vocabulary word. Discrete means that they are numbers that you count. So we count the number of goals. We count the number of shots. On the previous lesson, we count the number of baskets made. We count the number of shots taken. So those are things that are called discrete, things that we can count. If you can count it on your fingers, it's discrete. We're also going to look at the measurements one like we had on the last lesson as well. So simplify ratios involving measurements. So things that we measure. This one is a weight, tons and pounds. So we want to find a ratio where we've got the same unit of measure, meaning we don't want one of them in tons and one of them in pounds. We want to get them to just the same. So if we look down at the bottom, you have that same list again of different conversions, and we're looking for one that compares tons and pounds. And we've got one here. Every 1 ton is 2,000 pounds. So just so we know where that came from, I'm going to write 2 tons over 500 pounds, and I'm going to multiply that by the conversion factor. Now, 1 ton, I'm going to put that on the bottom on purpose so that the ton on the bottom and the tons on the top will cancel. And I'm going to put the 2,000 pounds on the top so that the pounds on the bottom and the pounds on the top will cancel. That leaves me with 2 and 2,000 on the top. That leaves me with 500 and 1 on the bottom. I can do 500 divided by 500, which is 1, and 2,000 divided by 500, which is 4. Means that I have a lot less work to do in the multiplying and dividing department at the end. 2 times 4 is 8. 1 times 1 is 1. So it's an 8 to 1 ratio, or we can say 8 to 1. So 2 tons to 500 pounds, that is an 8 to 1 ratio, or 8 over 1. Now you'll notice that I don't have any units left. And a lot of times students look at this and they're like, but you had a 2 on top and a 500 on bottom, Mrs. Fraser. How'd you end up with a bigger top number and a smaller bottom number? And that's because the units were different. 2 tons. Guys, think about that. That's like cars, okay? 500 pounds is not as much as 2 tons. So I actually have a bigger amount on the top because of the units than I do on the bottom. So when I compare them, getting rid of the units, I have a bigger amount on top than I do on bottom. All right, and the second one that's there, we're going to do blue for this one, 9 days to 90 minutes. And I don't have a conversion down at the bottom for how many minutes in a day. And that might not be one that you know. So we're going to say, all right, we can play that game. 90 days, not 90, I will get that, over 90 minutes. So that is 9 days over 90 minutes. Do we know any kind of conversion that has to do with minutes or days? And I happen to know that, days is longer than minutes. So I'm going to say every 1 minute has 60 seconds. No, it doesn't help me. Ooh, I do know that every 60 minutes is 1 hour. That'll work. I can cancel my minutes that way. 60 minutes is 1 hour. Okay, so that's a conversion fact. I know that there's 60 minutes in an hour. Now I've got hours and I'm trying to get to days, and I know that there are 24 hours in a day. And if anybody's watching this and going, how did she know where to put them? Well, there was an hours on the bottom, so I put the 24 hours on top so that they would cancel. Now there's a day on bottom that can cancel with this one way back here, and all my units are gone. You could do some simplifying. You could simplify the 60 and the 90, right? 60 divided by 30 is 2. 90 divided by 30 is 3. You could also simplify that 3 with the 24. 3 divided by 3 is 1. 24 divided by 3 is 8. I don't have anything else left on the bottom. So 9 times 2 times 8 is 144. 1 times 1 times 1 is 1. And so again, you're going to look at this and say, you know, Mrs. Frazier, I don't know how you got 144 to 1 or 144 over 1. How did the top end up a bigger number than the bottom? Well, 9 days is a way longer amount of time than 90 minutes. Even though the numbers are different, those units are what really create the value. So 9 days is much longer than 90 minutes. So when I've gotten rid of all the units, the top number is much longer than the bottom number. Now, both of these things were things that we measure. They are called continuous. And that is a new vocabulary word. Continuous is the word for things that we measure. Anything that is measured in time, measured in length, measured in weight, those all fit under a category of continuous. So these are continuous values, and the one up at the top was, again, a discrete value because we counted it. All right. Compare each pair of ratios using greater than, less than, or equal to. First, put each ratio in fraction form, lowest terms always. B, compare if possible. If you have fractions with unlike denominators, there are some choices. So let's get started and then see where we go. So 15 comedies out of 21 movies. So let's say, right, comedies and movies. Comedies is a type of movie. So this is something that we count. It's discrete. So we would say it's a 15 to 21 ratio. I can put that in lowest terms, 5 to 7. I also have 7 comedies out of 9 movies, and 7 over 9, well, geez, this really doesn't get me anywhere. I have uncommon denominators. So one option is to convert them to decimals. I'll tell you, neither of these decimals are very friendly. Getting a common denominator is another option. So the common denominator for 9 and 7 would be 63. So I could do times 9 and get 45 63rds. And I can do times 7, so I also get a denominator of 63, and it would be 49 63rds. So which one is greater? The 49 63rds is greater. So we're going to go back and we're going to look at the original fraction. This one was greater than this. So we would say the first one, 15 out of 21, is less than 7 out of 9. Always go back to the original ratios. You never compare the ones that you created, because we're saying if this top one was Netflix and the bottom one was Disney Plus, and we wanted to know who was showing more comedies, we would say that the top one, Netflix, is showing fewer comedies than the second one, Disney Plus. All right. So now we've got 21 boys out of 45 students and 13 boys out of 25 students. All right, so 21 out of 45. If I put it in lowest terms, it's 7/15. The second one is 13 out of 25. If I put that in lowest terms, it's 13/25. Now, not common denominators. I could go that route. I could also go with the decimal. But there's a super cool one here that says use greater than half versus less than half. Closer to 0 versus closer to 1. Well, 7/15 is just a little bit less than half. Okay, and 13/25 is just a little bit more than half. So that tells me the one that's more than half is a little bit bigger than the one that's less than half. So we can say 21/45, that's your original fraction, is less than the one that's a little bit more than half, 13/25. And always, again, go back to the original fraction, the original numbers. You might say, you know, one teacher has 21 boys out of 45 students. The other teacher has 13 boys out of 25 students. Which one has more boys in their classroom? And you're like, well, the first one has more boys, but that first teacher has way more students. So let's look at it as a ratio. The first teacher has less than half of her students' boys. The second teacher has more than half of her students' boys. So we would be able to say that 21/45 is less than 13/25. All right, so far we have used get a common denominator. We've also used greater than half versus less than half as strategies. 54 correct answers to 9 incorrect. 66 correct answers to 11 incorrect. Now this is called a part-to-part ratio. We don't do these often, but a part-to-part ratio is where we say, oh, you know, this person got 54 part of the answers correct, and the other 9, the other part of the answers incorrect. Most of the time we do part to whole. So this is going to be a little bit different when you think about what type of thing we're asking. 54 correct answers to 9 incorrect answers. If we put that in lowest terms, if we divide by 9, we get a 6-to-1 ratio. That means this person got 6 correct answers for every 1 incorrect answer. The next person got 66 correct answers compared to every 11 incorrect answers. They also had a 6-to-1 ratio. So these two people had equal ratios. Even though the first person answered fewer questions, had fewer questions on their test, the first person, you know, actually did a total of 63 questions. The second person did a total of 77 questions. They had a matching ratio. So that's kind of neat. That happens every once in a while. The last strategy that's there, convert them to decimals. You can always do that by doing the numerator divided by the denominator. And that will always give you a decimal version of your fraction. Alrighty, so I am sure we will have some questions tomorrow. Can't wait for it. Can't wait to hear them. Have a great day.